Okay, in this tutorial we're going to be looking at some double angled formulas. So we're saying that sine of a plus b equals sine of 2a since a equals b. Okay, so we're saying if b equals a, okay, then this is going to turn into sine of 2a. So we can say then that sine of 2a equals 2 sine of a cos of a. And if we look at the same idea with cos, then cos of 2a equals cos squared of a, take sine squared of a, or cos of 2a equals 1 minus 2 sine squared theta a, or cos of 2a equals 2 cos squared of a, take 1. So we've got three different variations for cos of 2a, and tan of 2a equals 2 tan of a divided by 1 tan squared of a. Okay, so we'll start having a look at some work examples. So the first one we'll look at is find the exact value of sine of 7 pi over 12 cos of 7 pi over 12. So we need to find the exact value of that. Okay, so we're going to be thinking, well, sine of a cos of a equals a half sine of 2a. So that's just rearranging our original one, which is sine of 2a equals 2 sine of a cos of a. So just rearranging that a little bit because we've got sine times by cos. Okay, so we also know that we can say, well, a is equal to 7 pi on 12. So we sub those values in, so we get sine of 7 pi on 12 cos of 7 pi on 12 is going to equal a half times sine of 2 times 7 pi on 12. Okay, so we get our half sine, okay, well, 2 times 7 pi on 12 is just going to be 7 pi on 6. Okay, you can see we're bigger than pi there, so we're going to be in the third quadrant. Okay, and sine of pi on 6 is equal to a half. Okay, so we're going to have a half times sine, as I said, sine of pi on 6 is also a half. But 7 pi on 6 is in the third quadrant, which means sine is negative, so it's going to equal negative a quarter for our answer there. Okay. Next work example, okay, is we're saying if cos of a equals a quarter, we want to find the exact value of sine of 2a, cos of 2a, and tan of 2a. So if I want to find the exact values of all of those given that cos of a equals a quarter. Okay, so we need to actually draw a triangle here, okay, because we need to think, well, cos is adjacent over hypotenuse, so we need to say, well, we've got some triangle here. We have 1, 4, and a, oops, in there. So then we go, well, a bit of Pythag will give us that we've got 4 squared take 1 squared, okay, will equal, we like this side here, x, it'll equal x, okay, which means we've got the square root of 16 take 1 will equal x. So we're saying the square root of 15 will be x. Okay, so we know this side is root 15. Okay, so that means then that sine of a is opposite over hypotenuse, so it's root 15 over 4. Okay, and tan is opposite over adjacent, so it's root 15 over 1 or just root 15. Okay, so we've got all those bits, so now we just need to work out, okay, well, what are all of these? So sine of 2a is equal to 2 sine of a cos of a. Okay, so that means we've got 2 sine of a is square root of 15 over 4. Cos of a was equal to 1 over 4. Yep. So when we simplify that, we get root 15 over 8. Then we go, okay, cos of 2a. Now we can do one of our 3 different ones, but we'll go for cos squared of a, take sine squared of a. So we know cos squared of a is 1 on 4, so it's that squared. So 1 on 4 squared, take sine squared of a, which is root 15 over 4 squared. Which means we've got 1 on 16, take 15 on 16, okay, which means we have negative 14 on 16 or negative 7 over 8. Okay, we'll just squeeze in 10 down the side here. So for 10, remember 10 of 2a is equal to 2 tan of a over 1 minus tan squared of a. So we've got 2 times tan of a was root 15, so we've got 2 root 15 over 1 minus tan squared of a, so it's root 15 squared. So we've got 2 root 15 over 1 minus 15, which is minus 14. Okay, so we can say we're negative root 15 over 7. Okay, so in this case we've done what we've done in a couple of our previous tutorials. We've actually used our basic definition of cos to set up a triangle. Okay, from there found our unknown side. Okay, and now that we've got all 3 sides of our right angle triangle, we could find what, well, we knew what cos was, we could find what sine and tan was, and then simply use our 3 identities there. Okay, so we'll go on to the next worked example, okay, which is solve for x if sine of 2x plus root 3 cos of x equals 0. Okay, we've got to solve for x. We know that x is an element of 0 to 2 pi. So we're given a domain here, what our x values can be, so we're expecting multiple ones here. So what we're going to do is write out sine of 2x using our identity. Okay, so we're going to actually change this using our identity to say that we've got 2 sine of x cos of x plus root 3 cos of x equals 0. So that's our first step there. Okay. Then we need to think, okay, well, we can collect a couple of like terms here. Okay, let me just make sure I've got this right. Yep, so yeah, what we're going to do, sorry, not collect like terms, we're going to take cos out as a common factor. So we're saying we've got cos of x outside of, we've got 2 sine of x, plus root 3, okay, equals 0. So by our null factor law, okay, null factor law says that either this or this has to equal 0. So we get cos of x equaling 0 or 2 sine of x plus root 3 equals 0. Okay, so we'll start off with here, because we know that when cos equals 0, x has to, when cos is 0, x has to equal pi on 2 or 3 pi on 2. Okay, they're the only ones in our domain that work. So remember, it starts at pi on 2, and we keep adding pi. So we get our 3 pi on 2, we go again and get 5 pi on 2, but we're going to be outside our domain. This one we need to solve, and we say, well, sine of x equals negative root 3 on 2. Okay, so then we go, okay, well, when is sine negative? Sine's negative in the 3rd and 4th quadrant, we know that. Okay, and when do we get root 3 on 2? Well, we get root 3 on 2 for x equaling pi on 3. Okay, but we're not using our 1st or 2nd quadrants, so we'll use our 3rd. So that means that x is going to be pi plus pi on 3, and we can use our 4th quadrant, which is 2 pi minus pi on 3. So we get 4 pi on 3 and 5 pi on 3. Okay, so all up, okay, our solutions are x equals pi on 2, 4 pi on 3, 3 pi on 2, and 5 pi on 3. Okay, so that is that work example done. Okay, we're getting there, but we've still got a little bit to go. Okay, so the next one, it looks ugly, but it turns out to be not too horrible. So we've got to prove an identity. Now this time our identity is cos of 2a, cos of a plus sine of 2a, sine of a divided by sine of 3a cos of a, take cos of 3a sine of a equals a half cosec a. Now I did warn you, this one did look ugly, okay, but it's not as bad as what we think. Okay, because what we can do over here, okay, is when say our left hand side, okay, our numerator can simply be cos of 2a minus a, because you'll see we've actually got our compound angle formula there, okay, over sine of 3a minus a. Okay, so these are some of our formulas that we've seen in our previous tutorials. Okay, so that helps us a fair bit because we can say that our left hand side, okay, is equal to cos of a over sine of 2a. Okay, and we know that sine of 2a is equal to 2 sine of a cos of a. So our coses can cancel out. Okay, leaving us with 1 on 2 sine of a. Okay, which simply goes to a half cosec of a as required. So as I said, this one's quite an ugly looking example to start off with, but it's our compound angles there, okay, and we're just using those to get to here, then just simplifying through to get to what we need. Okay, so I've got 2 more worked examples to do. So I'm going to have a look at the next one, which is prove the identity where cosec of a take cot of a equals tan on a divided by 2. Okay. So in order to do this, we've got some new equations that we need to do. So what we're using for this, okay, is we're saying that if we replace a with a on 2, okay, what happens then to our formulas? Well, that means that instead of having sine of 2a, we've got sine of a again, and that equals then 2 sine of a on 2 cos of a on 2. Okay, and our cos formulas become cos squared of a on 2. That one makes sense. Take sine squared of a on 2. Okay, which is the same as saying that we've got 2 cos squared of a on 2. Take 1. Or that we've got 1 minus 2 sine squared of a minus 2. Okay, so we're using those double angle formulas, but now what we've got is what we call our half angle formulas. Okay, so we've got half angle formulas for these ones. Okay, so what we're doing is we're looking at using our formulas here, okay, to get to this problem. Okay, so what we need to do is we need to go, okay, let's look at our left hand side again. So just go like this for a second. Okay. So we're going to look back at this worked example now. Okay, we look at our left hand side. So our left hand side, our cosec of a, well we can write that as 1, this is our left hand side, as 1 over sine of a. And then we can look at our cot. Well, we know that is actually cos of a over sine of a. Okay, which is quite nice because we can bring them together. Say that we've got 1 minus cos of a over sine of a. Okay, so we're getting there a little bit. Okay, and we can see here that we're going to actually be able to rearrange that a little bit too. This one here, 1 minus cos. Okay, so what we're going to do there is we're going to come up here and we'll say, well, that's going to be the same as 2 sine squared of a on 2, okay, divided by 2 sine of a on 2 cos of a on 2. So we're just using our appropriate double half angle formulas here, okay, with a little bit of rearranging. Okay, so up here, okay, well, we can get rid of our 2's. Okay, they're going to cancel out for us. Okay, and also our sine squareds are going to cancel out. Okay, so we've got a sine here and the square cancels out. Then we've got sine on cos, okay, which equals, of course, tan of a on 2. Okay, so it was utilising some of these half angle formulas this time. Okay, and we've got one last worked example. It's another identity question. So we're prove the identity that cos of 3a equals 4 cos cubed of a take 3 cos of a. So we've actually got some cos of 3a and we've also got cos cubed. Okay, so a little bit different. Okay, and just like a minute ago, we've actually got some identities we can use. Okay, so we're calling these our multiple angle formulas. Multiple angle formulas. Okay, so we've got sine of 3a equals 3 sine of a take 4 sine cubed of a. Cos of 3a equals 4 cos cubed of a take 3 cos of a. Tan of 3a is equal to 3 tan of A take tan cubed of A divided by 1 minus 3 tan squared of A. Okay, so they're similar to what we had earlier, just a little bit different. Okay, and we've also got our sine of 4A equaling cos of A outside of 4 sine A take 8 sine cubed of A. Okay, so you can see we're getting quite a bit more complicated when we keep going up our multiples. Cos 4 of A is equal to 8 cos squared, cos to the 4 of A take 8 cos squared of A plus 1. Okay, and tan of 4A, and you might have been able to guess, okay, that this doesn't look very nice. That's 4 tan of A, okay, 1 minus tan squared of A divided by 1 minus 6 tan squared of A plus tan to the 4 of A. So it certainly isn't a pretty one, okay, but we can use it to solve this. So I might just flick over the page, running out of a bit of room here. Okay, so we have our cos 3A equaling 4 cos cubed A take 3 cos of A. Okay, so we've got to prove that identity. So our left hand side, okay, we can think of that as cos of 2A plus A. Okay, so we're thinking of our left hand side like that, because we can do that, and that means that we can say, well, this is equal to cos of A cos of 2A take sine of A sine of 2A. Okay, and then we know that cos of 2A is equal to 2 cos squared A minus 1, and we also know that sine of 2A is equal to 2 sine A cos A from our previous work. So when we do that, okay, we can say then that cos of 3A, okay, basically we can sub all of these parts into here. So you can say, well, we've got our cos of A, and we've got to times it by all this, by our 2 cos squared A take 1, okay, minus sine of A times 2 sine of A cos of A. Okay, so just subbing these parts into here. Okay, subbing those parts into there. Okay, and we can simplify further. Okay, and say, well, that's the same as 2 cos cubed of A, so expanding out these brackets, minus cos of A. Okay, take 2 sine squared of A cos of A, expanding out those brackets again. Okay, and then we know that sine squared of A, we know that equals 1 minus cos squared of A. Okay, that's one of our identities that we know, and we can put that in. Okay, we can put that into here. Okay, and when we do that, we find that our cos of 3a, okay, is going to be equal to 2 cos cubed of a minus cos of a. Okay. Take 2 times 1 minus cos squared of a, cos squared of a, cos of a. We're almost there, because we can simplify that down a little bit further. Get 2 cos cubed of a, take cos of a minus 2 cos of a take cos cubed of a. That's just simplifying a little bit, which we finish off by saying, well, that's the same as 4 cos cubed of a take 3 cos of a, which is what we're trying to get to up here. So this one's been a bit of a trickier one. Okay, so the first idea was, okay, let's modify this left hand side so that cos of 3a is actually 2a plus a, and then that way we could use our double angle formulas, which we just wrote down, substitute our double angle formulas in where we could. Okay, also had to put in this other identity here too. Okay, and then simplify down. So there's a fair bit of work there with substituting and simplifying down and everything. If you set things out well and you keep it organised and you keep the layout really good, then you can work through it in a logical manner. So hopefully that's enough to get you going on those questions. I know this one was probably a bit of a longer section, but hopefully that'll be enough to get you through.